Hello friends, welcome back to the tetrahedron chemistry classes. So guys, in today's class I am going to discuss another very important topic from 2D NMR spectroscopy, and the name of the topic is the Tocsy, which stands for the total correlation spectroscopy. Okay, so in some of my lecture, say 2 months back, I have covered the interpretation of your COSY NMR spectrum, right? So COSY is another 2D NMR technique, which is the pretty basic one. And after that, I am coming back to coming to this topic, Tocsy. So before going into the details of the Tocsy interpretation, right? I will cover only the interpretation part. I am not going to discuss how the experiment will run actually, right? But but only cover the interpretation, how we look the spectrum, how we analyze the spectrum to characterize a particular compound. Okay, so for this, first of all, we need to know what actually the COSY tells you. So COSY means correlation spectroscopy, and please remember, COSY gives cross peaks. Okay, see, the students who have already watched my COSY lecture, दोस्तों, मैंने एक ये नया चैनल जो है एक डेली व्लॉगिंग का स्टार्ट किया है, जिसको देवलोग माई व्लॉग के नाम से जानते हैं। आप मुझे सपोर्ट करिए, जैसे आपने मेरा चैनल टेट्राहेड्रॉन केमिस्ट्री क्लासेस सपोर्ट किया है, वैसे इसे भी सपोर्ट करिए। प्लीज़ चैनल को सब्सक्राइब करिए, इसको शेयर भी करिए सब लोगों से। थैंक यू वेरी मच। दे विल नॉट फेस एनी प्रॉब्लम. And for the students who are new here and watching this video for the first time, it's my request, first watch COSY interpretation of the COSY spectrum by tetrahedron chemistry classes. Okay, I am giving you the link in the description box also. Okay, otherwise you can straightforward type in the search bar of your YouTube COSY interpretation of the COSY spectrum by tetrahedron chemistry classes, then you will get the result and you can understand the things very easily. But for now you should know whatever the cross peaks would be there in the COSY spectrum, right? These cross peaks these cross peaks in COSY spectrum only for directly coupled nuclei. Directly coupled nuclei. What is the meaning of that? Say for example, you are having CH3, you are having CH2, and then you are having CO here, and then you are having CH2, again CH2, again CH2, and CH3, like you are having this compound. Okay, this is how you can see. So what you can see here in that case, see, if you are looking for the COSY, so what actually the COSY will tell you, right? This is something very important, what the COSY will tell you. Okay, so you have heard a little noise, and that noise is coming from my PC itself. Please ignore that. I'll take care of that noise in the upcoming part of the lecture. Okay, so now if you are looking for the COSY, right, so COSY will give you the cross peaks which will relate these two, right, these three hydrogens and these two hydrogens. Remember, COSY spectroscopy is the correlation of the protons, right? And in Tocsy also we will correlate the protons only, will not correlate carbons. We are only looking for the correlation of the hydrogens. So in the COSY spectrum, these two will actually the cross peaks would be there, these due to these two and these three, because they are directly coupled, they are directly J coupled. So what is the meaning of the J coupled? For example, if I write CH and H here, right, and then my H and H. Okay, this part actually I am drawing here. So this hydrogen, right, you can see here, this hydrogen is 1, 2, 3. So it's a 3 bond coupling, 1, 2, 3. So they are directly J coupled. So they will give the cross peaks, and same is true for these two hydrogens as well as for this hydrogen. Similarly, if you check the COSY of this compound, so correlation between this CH2 and CH2 would be there. You will find the peaks for these, right? And then you will also find the peak correlating these two nuclei, and you will also find the peaks correlating these two nuclei. So what I am trying to explain you, in the COSY the correlation in between these two would be there, and these two would be there, and these two would be there, like in that case, right? Here also the same is true. But if you are looking for the correlation between this hydrogen and this hydrogen, which are not directly J coupled, so in the COSY spectrum you will not find the cross peaks which actually correlates these two. Similarly, you can see if I say this hydrogen and this hydrogen, right? So you will, in COSY spectrum you will not find this thing. Okay. Similarly, correlation between this and this you will not find. Clear? And after that, in the COSY spectrum, you see, this is, I think this idea is sufficient to know the background of the COSY spectroscopy. Now I am coming back to the total correlation spectroscopy, that is Tocsy. See, in Tocsy you will get all the peaks which are there in the COSY spectrum, but some additional peaks would also be there. That means, you see, this hydrogen is connected to this one, and moreover this is connected to this one. So if you are looking for this particular peak, this would be there in the Tocsy spectrum. Similarly, if you are looking for these two cross peaks, they will be there in the Tocsy spectrum, and same is true for this and this also, right? Only this thing you need to understand. That's why it is known as the total correlation spectroscopy. However, in between them you see this carbonyl group is there, so you will not find the correlation between these two hydrogens and these two hydrogens. So there would be a gap due to this carbonyl group, right? Because no hydrogen is here. Sometimes your nitrogen may be present. Okay. So basically, what will happen in that Tocsy spectrum? Let's say the example, right? Say you can see here, this is my compound, and that compound is your ether, right? This is your ethyl propyl ether, or you can say the ethoxy propane. IUPAC name is the ethoxy propane. So first of all, what I can do, I can remove certain thing from here. Now you see here, if you see this spectrum, let me shift. What I have done, I have already given you the chemical shift of these hydrogens which are there in the this compound. Similarly, CH2 and CH3 is there, and in between this oxygen is there. So now recall, if you are looking for the COSY, then only these two correlation would be there. And if you are looking in the COSY again, so these two correlations between C and B would be there, and between B and A would be there. Okay. First of all, you see, this is the type A proton which is having the chemical shift at 1.0. So I have written here, you see, this is a 1.0, and this 1.0 for, say, suppose for this one. Okay, this one. And then you see again, you are having another proton set E, which is having the chemical shift of 1.1. So here the red one is, again I am showing you, this is 1.0 for A, this is 1.1, this is for E basically. So if you want, then you can write E also here. Okay, E. However, I have already written here, but it is not quite visible. And after that, what you can do, guys, you see, I am having the chemical shift at 3.37, which is type C proton. So here you can see I am having the cross peak here. Okay, and that cross peak is due to the this one, right? 3.37 due to these. Where is that? Yes, this type C. Okay, and then you see after that 3.41, which is due to this proton, type D proton. So I have written here type D proton. So these are in the these are the sum of the chemical shift. Okay, so how we can look for the correlation, right? So first of all, what I am trying to explain you see, if you are looking for the blue peak, first of all, see, please note this particular point. In the COSY spectrum, you will not find this kind of the color coding between the cross peaks. Okay, so this is your basically diagonal. So let me shift this again, because I have changed this. Right now, this is looking more appropriate. Now this is looking more appropriate. The peak actually, which generally we have missed, actually you can see here. This is C, right, which is this red one. C is this red one, 3.37. Okay, and this 3.41 is basically this D. So what you can do, you can write D here also. So I am writing D here, right? So you are having all the protons here, like A, B, C, D. You are having all the peaks here. Say this is A, this is B, this is C, this is D, this is E. Now if you only focus on this blue peak, blue cross peak, see this is the diagonal, this is the diagonal, and the top side of the diagonal you are having the cross peaks, and here also you are having the cross peaks in the bottom part of this. Okay, now if you see here, this blue, if you travel from here to here, just like that, so this blue is correlating to this blue. That mean the type what you can see at 1.0, right? It's not, sorry, not 1.0, 1.1. This 1.1 is correlating to 3.4. Okay, 3.4. Okay, so this correlation is there, which is just like the COSY correlation, and it is quite obvious. You can see here at 1.1 you are having this type E signal, which is this one. Okay, please, no, sorry, this is blue, this is one, and at 3.41 you are having the type D. So this is having, so these are having the correlation. Okay, so if you want, then what you can do, you can connect them just like that. And if you go up, so it is connecting to this one, and it is connecting to this one, and this is again, if you come down, this is connecting to this one. So this is one set of the proton, right? This is one set of the proton. That means one spin system. So what you can do, you can name them as spin system. दोस्तों, मैंने एक ये नया चैनल जो है एक डेली व्लॉगिंग का स्टार्ट किया है, जिसको देवलोग माई व्लॉग के नाम से जानते हैं। आप मुझे सपोर्ट करिए, जैसे आपने मेरा चैनल टेट्राहेड्रॉन केमिस्ट्री क्लासेस सपोर्ट किया है, वैसे इसे भी सपोर्ट करिए। प्लीज़ चैनल को सब्सक्राइब करिए, इसको शेयर भी करिए सब लोगों से। थैंक यू वेरी मच। स्पिन सिस्टम, ओके, and then what you can do, you can focus on this red, right? This is at 1.0 ppm, right, which is your 1.0 ppm, that is type A, which is this one, A at 1.0, right? If you travel, then you will find another red peak, okay, and this red peak is at 1.5 ppm, right? These two are correlating, and it is quite obvious. You can see here this correlation is there. This A is correlating with B at 1.5 ppm. So A is correlating with, you can see here, this A is correlating with B, and then you can see this B is also correlating with the 3.37 at C. So if you travel further and came here, then you will find the peak at 3.37, right? So these three peaks are correlating to this one, and it is just like that. See, A is correlating to B, then B is, see, A is coupling with B, B is also coupling with A. Similarly, B is coupling to C, C is also coupling to B actually. So this correlation actually is there, and this correlation is also there. However, they are not directly J coupled, right? But this correlation you can see here, and it is quite obvious because these three are there. Okay, so this is what you can do. If you want, then you can draw one line from red also, just like that, red, and then you can go up. Red will meet red, and then you can come here, and then you can go down, just like that. So this is another spin system. That means you can say this is another spin system. Spin system. Say this is spin system 2, or this is spin system 1. Okay. So however it is, you can give any number to anyone. You can give any spin number you can give you. So I am writing spin system here. You see, you can write this as a spin 2 or this as a spin 1, spin system 1. This will not make any difference. Okay, so this correlation it is showing, but in that case you can see the important thing which you are not observing. This C, because the oxygen is there, that means this C cannot couple with this 3.41. C cannot couple with D. That's why if you check here, this C is there, right? This C is there. This C is there in the form of the red, but here you will not find any D, because D is there. So they are not correlating. That means they are not coming in the same row. The protons actually which will correlate, actually which are correlating, they will actually lie in the same row. But you see this D is not in the same row. That means this A, B, C, they are not correlating with the D. And same is true for this one. This A is not correlating with this E also, right? Because this was E actually, the blue one was E, right? So they are also not correlating. So in that case, you see two spin systems are there, and I am telling you this is the interpretation which you are doing, okay? But this total correlation spectroscopy is not of very much of use when it comes to the small molecules. It is just for the explanation. But this Tocsy correlation is very, very important for the researchers who actually who are doing this peptide chemistry, right? In the characterization of the peptides of the proteins, where you will have the lots of the spin system. Then see the number of the square which you will form, one square will represent one spin system. If you have the 2 square, then it will have 2 spin system. It will have the 3 square, then you will have the 3 spin system. In that case, only 2 spin system are there. First is this one and second one is there. That's why only 2 square are there in that case. Okay. And here again you can see this blue one, which is this one, right? This is correlating to this one, right? At this particular point 3.41. Okay. But it is not correlating to this particular system. This is something very, very important. And one more important thing you can observe here, how many peaks we are having, including your diagonal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total 13 peaks are there. So in that case, please remember, in the different spin system, the numbers of the protons you are having, the number of the proton sets you are having, and that will decide your number of the cross peaks. So basically, say if you have your n number of the protons, so cross peaks would be n into n, right? Say for example, if you have two proton system, so 2 multiplied by 2, that will give you the 4. And this is true here. You see one set of the proton is this one set of the proton is this one. That means total 2 sets are there. In that case, you see here 2 sets, this is set 1, this is set 2. So 2 multiplied by 2 equals to 4. Now here you can see one type of the protons, second type of the protons, and the third types of the protons. So total 3 types of the protons are there. So cross peaks would be how much? 3 into 3. Okay, that is 9. So since we are dealing with the correlation spectroscopy, so all the correlation would related to this spin system as well as this spin system, they will be there in the Tocsy spectrum. So total peaks, total cross peaks would be the sum of the peaks of this spin system as well as this spin system, that is 4 plus 9. Okay, and 4 plus 9, you know, it is 13. So total 13 cross peaks are there, which I have already explained you. And one more thing I am going to give you the idea about that thing. See, before going into the interpretation of your 2D NMR spectroscopy, you should be very careful about the, you should have the very clear-cut idea about the proton NMR spectrum. You see here in that case, 2 triplets are here, right? 2 triplets. Okay, 2 triplets means here one triplet is this one, okay, and another triplet is this one. Both this is having 1.0, this is having 1.1. And in proton NMR spectrum, they are actually quite they are overlapping. So you cannot say with the certainty that which triplet is belonging to which type of the system. However, if you apply the basic knowledge of your basic organic spectroscopy, then you can straightforward say that the signal which we are appearing at 1.1, this is due to this one because this electronegative oxygen is there, and at 1.0 this proton is there, right? But if you want to make the clear-cut differentiation between if you want to differentiate clearly between these two, then you have to take the advantage of this one, right? You see here this E is correlating with D, but this E is not correlating with A here, as I have explained to you. right? So this is just one example. Let's take one more example. Okay, दोस्तों मैंने एक ये नया चैनल जो है एक डेली व्लॉगिंग का स्टार्ट किया है, जिसको देवलोग माई व्लॉग के नाम से जानते हैं। आप मुझे सपोर्ट करिए, जैसे आपने मेरा चैनल टेट्राहेड्रॉन केमिस्ट्री क्लासेस सपोर्ट किया है, वैसे इसे भी सपोर्ट करिए। प्लीज़ चैनल को सब्सक्राइब करिए, इसको शेयर भी करिए सब लोगों से। थैंक यू वेरी मच। ओके, दिस कंपाउंड यू कैन सी, दिस इज इथाइल वैलेरेट। बेसिकली दिस इज द एस्टर ऑफ द वैलेरिक एसिड। ओके, and in that case again you see this is your ester part, C double bond O, and this is your one spin system, guys. This is your one spin system and this is your another spin system. That means two spin systems are there, and this system, and there is a gap due to this carbonyl group. So how many, first of all, how many cross peaks would be there? So I have already given you the trick. Say if you check here, you see only two sets of the protons are there. That means 2 into 2, 4. So you can write 2 multiplied by 2 equals to 4. And after that here you can see this is set 1 of the protons, set 2, set 3, set 4. Okay, 4 sets of protons are there. That means 4 into 4 equals to 16. If you add all of them, then it will give you 20. That means this must have your 20 cross peaks. So you can count all the 20 cross peaks. You see, I am counting from here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So total 20 peaks are there. Now in this spectrum, right, in this spectrum, they have already marked the types of the hydrogens are there. So this is your F1 domain, this is your F2 domain, or you can call it as you can call it vice versa also. F2 F1 or F1 F2, it will not make any difference, right? Especially when you are doing the interpretation. Okay, now the knowledge which you are having about the total correlation spectroscopy, that means this 6 will couple with the 7 and 7 will also couple with the 6. That means there should be the cross peaks which are correlating with which are correlating the cross peaks which are correlating type 6 of hydrogens and type 7 of hydrogen, right? This correlation must be there. So let's check where the type 7 of the hydrogens are there. So you see this peak, right? This peak, you can see here, this peak is the type 7, and you come here actually. This is the cross peak, right? However, it is at the diagonal, right? But it will not make any difference. This peak is showing the position of the 7, and that 7 must correlate with the 6. So if you move from here to here, it is correlating with this cross peak, and this cross peak is of 6. That means correlation between 6 and 7 is there. So if you want, then what you can do, you can connect them like that. Okay, you can connect them like that, and then you see you can come here just like that. This is again, you see the 6, this is 6, this is the cross peaks of the 6. Okay, and then what you can do, you can come here, and this you can very easily see, this is at here 1.0, right, which is again correlating with this 7. Okay, so if you want, then you can connect them like that. So this is one spin system which is there in that case. Now if you check this particular spin system, so there would be a correlation between 1 with 2, 2 with 3, 3 with 4, or 4 with 3, 3 2, and 4 with 3, 3 with 2, 2 with 1. This correlation must be there actually. So what we will do, we'll check where is the cross peaks related to this types 1 of the hydrogen. This is H1, right? I am calling this H1. So this is your H1, and this H1 peak is there. Okay, and now this H1 is correlating with H2, H3 and H4. So this cross peaks must correlated with the H2, H3 and H4. So this is the H1, and if you come here, this peak is there, which is due to the H2. So it is correlating with this one. If you move further, so this is again correlating with the H3, right here, and then if you move further, it is again correlating with the H4. But you see there is no cross peak here, right? Why no cross peak is there? Because this carbonyl moiety is there, the ester moiety is there. That means none of these can correlate with this 6 actually. That's why you are not finding the cross peak here. Only the cross peak which can correlate, cross peaks which can correlate all these hydrogen of this spin system are there. Similarly, you see this one is not correlating with the 7 either. You see here, this is 7 and you are not having any peak related to the 7. So this is another spin system which is correlating type 1, type 2, type 3 and type 4 hydrogen. So if you want, then what you can do, you can connect them all like that. Okay, and same type of the correlation you can see, you can check here in the downward also. This is H1. If you come here, it is correlating with the H2 here. Okay, then come here, this is correlating with the H3 here. Then come down, it is correlating with the H4. But again you see it is not correlating with this H7, right? Because regarding to this H7 you are not having any peak. You are not having any peak here, right? So this is how you can do. So this is another spin system. So what you can do, you can mark them just like that. And then similarly you can connect all of them because they are more or less showing the same thing. H1 is correlating with the H2 and then with the H3 and then with the H4, but no cross peak here related to this H6, so there is no correlation. No cross peak is here actually to correlation this one because this 6 and 7 is the different spin system and these cannot couple with this spin system. So if you again mark them just like that, so this is another spin system. So this is spin system number 1, this is spin system number 2. So this is all about the interpretation of your Tocsy, right? Tocsy interpretation. So let's check in the next page, right? So whatever I have explained you, this all peaks are there actually. This correlation they have explained here, this correlation they have explained there. If I go back, see, you see here this correlation and this correlation. If I go back, then you will find the same correlation. Okay, there is no difference in this and this. Okay, only artistic way is different because I have drawn with my hand and it is done by the computer itself. Okay, and of course not forget about the diagonal. Okay, this diagonal is also there, but there is no not much of very importance of this diagonal. Okay, just like that. Okay, now so this is about your all about your Tocsy interpretation. Now this is say your last example. And I am not doing this example, I am giving you the hint for this one. This is your heptanone 3. This is your heptanone 3. So whatever I have explained you and you have seen all these things, and if you have understood the things completely, then you can draw the structure of the heptanone 3 and then you can mark the spin systems, and the total number of spin system would be correlating here, right? The cross peaks relating the spin system would be here in that case. Okay, so this is all about your Tocsy interpretation. Okay guys, and previously you have seen the COSY spectrum. So that's it for today, but before signing out I am again making a request. You have already seen a couple of times the videos here, the link, the advertisement of my vlog channel, right? So if you are interested, please also support my that vlog channel and subscribe Devlog my vlog also. And if you are watching video for the first time, then it is double bonus for you as well as for me. You can subscribe tetrahedron chemistry classes as well as Devlog my vlog to support me. Okay, so we'll meet with the another concept of chemistry in the next class. So that's it for today guys. Thank you very much.